So today we're going to take a look at doing some basic math when you're playing a mobile game, specifically LoveNikki Dress Up Queen. If you haven't heard of this game, that's alright. You can still follow along because I have the instructions below. But if you have played this game, you've probably seen an event like this before, or you've seen this specific event. This is the Dream Builder event. And what happens in mobile games especially is usually you have to spend a certain amount of tokens, or you have to, there's a lot of microtransactions, there's a lot of things going on, so a lot of players of mobile games need to sharpen their math skills or just understand, what they're actually paying for. But in this case, we're not going to be dealing with real money and whatnot. That gets a little more complicated. We're just going to be looking at the tokens that we spent, specifically diamonds in this game. And if you haven't played the game, don't worry because we have instructions below. But if you have, you're familiar with this. So, you go in and you hit start. And obviously I can't because this is just an image. But you go in, you click start, and you've got choices on the screen. Every time you enter, if you want to take a chance at you're picking the right or wrong answer, you've got to pay 20 diamonds for one chance. And as you can see, my accuracy is only this much. Now, every time you get an answer wrong, you want to try again, and you have to pay 20 more diamonds to try again. Every pull is 20 diamonds. And so, if you think about it, I only have 85% accuracy. So somebody who has 95% accuracy or even 100% accuracy basically pays less diamonds than I did, because I would have to pay more just to get more chances in, because every time you get it wrong, you probably want to try it again. And usually at the end of these events, we might say, how many diamonds did you spend? How many diamonds did you spend? I got this many wrong, so I need to spend this amount of diamonds. But if you notice anywhere on this page, it does not tell you how many diamonds you actually spent, nor does it tell you how many total choices you pulled. You only are given your correct number of choices. And, well, when I played, I forgot to tally up the number of diamonds I had before I started the event, so I have no idea how many diamonds I actually spent. So we're going to look at this word problem I cooked up, and it's actually very important to learn how to do word problems, because when you can put an event that something that you're looking at in real life into words, you can pick out key elements and you can make a math problem based on it. So we're gonna read through this, and I'm going to show you how I structure these problems. So, in a mobile game, players pay 20 diamonds for one chance at the event. Every time you pay for a chance, you either get the question right or wrong. The game tracks how many correct choices you made and your accuracy percentage, but does not tell you how many wrong choices you made, nor your total number of pulls. You forgot to keep track of how many diamonds you spent, and the game doesn't tell you how many chances you paid for. With the given information, how can you find out the total number of pulls you made, and thus the total amount of diamonds you spent? So if we look above, my correct choices are 145. My accuracy was only 85%. So essentially what it's saying is 145 is 85% of some number, that number being the total number of pulls that I made. So, in other words, we are looking at, well, I got 145 correct answers out of how many total choices? How many times did I enter that pavilion and pay? So let's see. Essentially, as I described above, 145 is 80% or 85% of some unknown number. So, I know 145 is 85% of some of, well, my handwriting is not the greatest, some number. The thickness of some of these pencils are a little different. So we are going to translate this. We're going to translate this into an equation, and this is very important. With percentages, this is relatively easy to do. So 145 Well, that is just itself. I don't have a red pen here. Excuse me. Trying to make a red one. Where is it? Okay, there we go. So, 145. Well, that's just a number, so we're going to say 145 is. Now, what does is actually mean? In this case, 145 is the same thing as 85% of some number. That's really what it's saying. So is, in this case, translates to an equal sign. Now we have 85%. You might think just to put an 85 here, but it's not just an 85, it's 85%. And if we take a look at this and just kind of draw it off to the side here, 85%. Now, percent usually is a connected word, but it comes from the word percent. And the per sign, is this division sign. So you can think of it like this. 85%. Now, this doesn't mean cents as in dollars, but just cent. And we'll get to that in a minute. So, you know, sometimes you might see things like, you know, this is the unit price is like, you know, 5 cents per ounce. And this per here is written like that. So normally you might just memorize, if you have 85%, you need to move the decimal 2 places, but I'm going to quickly explain why that is. So cent actually means 100, you know, like century, for example. So 85% actually means 0.85. If you were to put that in your calculator, 85 divided by 100 is 0.85. However, a little bit of an easier way to remember this is if you have 85 and it needs to be, it's percent, and it needs to be converted to percent, this percentage needs to be converted to decimal form for the sake of plugging it into an equation. Most times, many people will just take the decimal and move it 2 places to the left, and then you've got 0.85. But if you don't memorize this process here, if you always go back in your mind and, you know, reference this idea, kind of like a little thought bubble, you will remember that this is how you translate this. Why do we make percentages into 0.85, but we don't do it with this number? Well, that's actually the reason. Now, 85% of some number. So in this case, of really means multiplication. And if you haven't taken percentages before, the gist is that, for example, if you have like a bill that is, you know, you have this much as your restaurant bill and they expect a 20% tip. Well, that's 20%, but 20% in decimal form is just 0.20. If you simply multiply these two together, that's how you get your total amount. So if we were to just plug that into our calculator real quick, you know, I assume some of you could probably do this in your head, you get $3.99. So anytime you take a percentage of something, you're just multiplying it. Because it's smaller, that's where the smaller number comes out from. So that's just another bite-sized lesson for you. Why is my eraser not working? I guess it doesn't feel like working today. That's very annoying. Okay, that's fine. We'll just leave that down there. But essentially, of means multiplication. In this case, because we're taking 85% of some number. Some number, we have no idea what this is, but that's okay. That's kind of the point. Sometimes I will denote that as a question mark. But in our math problems, we typically mean an unknown value is x. So in other words, this is 145 equals 0.85x. Now from here, all we need to do is some simple algebra. So we will just go ahead and divide by 0.85 on both sides. And we will get our answer. Now the issue is when you do this, in your calculator, I've got one handy with me, 145 divided by 0.85. The issue is you get an approximation, so that's going to be squiggly because it's not absolutely equal to, we're unsure. That's kind of why I think of the squiggly mark there. Oh, okay, I still can't erase those guys. So we've got approximately 170.58 8 something something something. Now, we don't really know if this means 170 pulls or 171 pulls. Because if we do the reverse, if we go ahead and say, all right, this could mean 170 pulls or 171 pulls. If we were to do the reverse and say, okay, let's take 85% of 170. And if we want to go ahead and do that real quick, let's just see what that is. 0.85 times 170. Put that in our calculator. That's weird. I got a different number. I think I might be doing this slightly wrong. Maybe not. All right, so we got 144.5, and that's not how many pulls we had. But if we do 0.85 times 171, we get 145.35. So we really don't know, at least I don't know, how the game, extracted this number, because they didn't give us a very accurate percent. They only gave us about that. So our margin, we're going to be off by 1 or 2, but that's fine. We'll just remember that it's somewhere we either paid for 170 chances or 171 chances. So we're just going to kind of keep that number here. This is our total number of chances here. Total number of chances. Now you might be thinking there is actually another way to do this. We could have done a proportion, and I see that this video is getting a little long, but it might be worth it to know. If you think about this, so let me see if I can do a different color for proportion. It looks like we don't really have one. But you could have just as easily, if we were to take a look at this information again, we could say, well, 145 out of some number is the same as 85 out of 100. And if we were to cross multiply, we're going to get the same answer. It's just going to be a lot larger. Because, we could, we could actually we could cross multiply, or we could just make this 0.85. But whatever you do, you're basically going to get the same result. We have 145 divided by x. Then we have to move the x twice. So I would say let's just go with cross multiplication. So we have 145.00 on this side, and then 85x on this side. And if we just divide both sides by 80, my handwriting is not happy today. 145, 00 divided by 85. We get the exact same thing as before, 170.588, da 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 da. And so, that's another way to do it if you were to set up a proportion. But I kind of think that translating to math problems a little bit easier. It's not being nice, and I can't erase that either. So I'm just going to put a 5 there, and we're just going to ignore that. I really hate that I can't erase right now. I don't know what's wrong with my program. Anyway. And a lot of you people who play this game, you're probably like, but you're forgetting the free tries. We are getting there. So, from this point, we could just say, okay, well, we remember that each pull was 20 diamonds, right? So, I probably should just highlight that. That's a really pretty important piece of the problem there. So, at the end of this, if this was the only part of the problem, which right now it is, unless you've played the game, you understand there's more. You might just say, well, let us try and multiply 170 times 20, and that would be our total number of pulls, right? Or total number of diamonds spent. Because if you spend 20 diamonds on each pull, the only natural thing to do is say, well, if I'm pulling 170 times, I need to times 20 170 times. 20 times 170 is... Hold on, 20 times 170, my fingers are slipping, is 3,400. However, that isn't all. In this game, which actually, this is not just a word problem, this is real. In this game, we forgot to consider. The game also gives the player 10 free tries per day until the event is over. That means you didn't actually pay for all the pulls you calculated above. So some of these pulls are free pulls, meaning I didn't pay for them, so I don't need to calculate my diamonds. How can you find out the real total number of diamonds you spent knowing this information? So we might have to go back up to the poster here. So it looks like this event ran from the 4th to the 10th. This is February 4th to February 10th. Now you might just think, all right, 10 minus 6, right? that is, wait, sorry, 10 minus 4, that is 6. But you're forgetting to count the 4th day itself, because you get the free tries on this first day as well. So you might just add 1 in your head, but for me, sometimes I'm just thinking about it. So the first day is the 4th. The next day is the 5th, and we get 10 each time. 10 free, 10 free. The next day is the 6th. Another 10 for free. Next day is the 7th. Another 10. Next day is the 8th. That was another 10. The 9th, we got 10 more free chances. And finally on the 10th, we got 10 more. Now if we add these up, 1, 2, 3, 4, 5, 6, 7, that is 70 free pulls total. And you don't really have to count those. We know that there's 7 days because we can look at them here. And we know that there's 10 per day. So in other words, we can just, you know, in our heads do 10 times 70. And that is how, I'm sorry, 10 times 7, which equals 70. So now we know we have 70 free pulls. And if we have 70 free pulls and our total number is 170, we want to know how much we paid for. Remember, if we have 70 free pulls and 170 totals, then how many pulls did we pay for? And the answer to this is pretty simple. You might have to think about it for a while, but essentially, you just take your total pulls and say, well, I'm going to cut out or subtract the pulls that I didn't pay for. So now all we have to do is remember, like above, we paid 20 diamonds for 1 chance. So, or 1 pull, they're the same thing. So this means that I paid for 100 pulls and I paid 20 diamonds each time I pulled it. So if each pull is 20 diamonds, and I paid for 100 pulls, how much or how many diamonds did I pay total? And that's pretty simple. We're just going to go ahead and take, nope, I'm a little new to this. Take 100 times 20. And we have, nope, that's wrong. Sorry, we have 2,000. Now, remember this 1 pull, we may have done 170 or 171. That just kind of means that it's possible that this may have been 101 pulls instead of 100, because we really don't know which it is because the game didn't give us enough accuracy. You know, 85% is slightly off than what it really was. It might have been 85 point something percent, or it might have been 84 point something percent. We really don't know. So we're off by 1. But in this case, it looks like if you were to just add 1 more pull, so this is plus 1 pull, and 1 pull is 20 diamonds. So we might say, well, if 100 pulls is 2,000 diamonds, then 101 pulls is just 20 more diamonds. So it ranges anywhere from, why did that happen? The number ranges anywhere from 2,000 to 2,020. So that looks a little bit messy down there, and I can't erase it again because this computer doesn't like me. Well, I guess I'm just going to go ahead and highlight that. I'll just highlight our answer here. So this is our answer. And we'll just take this on this side. No, that looks kind of messy. All right, well, I'm just going to scroll down a little bit. I'm just going to say this could be 220 if we add that possible extra pull, because we aren't totally sure. They didn't give us enough information to get us completely accurate. But the last part of the game is here. Finally, if you complete the entire event, which we did, the game awards you with 30 diamonds. How can you find out the net number of diamonds you spent on the event if you earned 30 back at the end? So the key here is net number. So, you know, if I spent $100, but then I found $10 on the floor, that day I only lost $90. So in this case, we spent 2,000 diamonds. Oops. We spent 2,000 diamonds. Just going to abbreviate that. And we earned 30 diamonds. So you might think, okay, 2,000 and then we're going to add 30. But actually, since we're trying to figure out how much we spent, earning is the opposite of spending. So we can subtract 30 diamonds from our total number of spent diamonds because we actually got some diamonds back. I don't know why I still can't erase that. I'll just have to cover it up. Okay. So all you have to do is say, well, if I spent 2,000 but I earned 30 back, then I really hope my math is right on this. Yep. Yeah. Okay. And if we're going to go ahead and use our 2020 number, you know, what if we spent 2020 diamonds? Because we don't really know. And so we can still just subtract 30 diamonds from there, and we spent 990 diamonds. So in this case, you know, we don't totally have a correct answer. But if your friends are asking you how many diamonds you spent on this event, and you're me, and you have my exact numbers, you can say I spent anywhere from, you know, 1,970 diamonds to 1,990 diamonds, or 1,970 diamonds to 1,990 diamonds. I'm not too sure. So if you guys if you've done this event and you didn't keep track of how many diamonds you earned or spent while you were playing other parts of the game, you might want to do this math problem and see how many diamonds you spent if you weren't paying any attention. Thanks for watching, and I hope I'll be back again to do some more math.